Welcome to the Hawaii Health Data Warehouse's Coffee Break Monthly Webinar Series. I'm Julia Chose, a public health epidemiologist with the Hawaii Health Data Warehouse, or HHDW. Today, we're going to be talking about a few data tips and tricks that can be helpful when using hhdw.org or hawaiihealthmatters.org. Specifically, we're going to talk about three things. First, we're going to examine age-adjusted rates, what they are, and when to use them. Second, we'll cover confidence intervals, what they are and how to read them. And last, I'm going to show you a tip about moving from Hawaii Health Matters to HHDW in order to explore your data more deeply. We'll start with age adjustment. There are many health conditions and risk factors that are associated with age. Here we can see the prevalence of diabetes by age. Like many chronic conditions, diabetes is more prevalent as age increases, but we can see trends in the other direction too. Here's the prevalence of binge drinking by age. So here younger individuals are more likely to binge drink than older individuals. So what happens if you're comparing two populations with different age structures? This is when you would use age adjustment. It allows a more accurate comparison of rates in populations that have different underlying age distributions. Basically, they are the rate that would exist in the populations if the populations had the same distribution as a standard population. And people commonly use the US 2000 standard population for age adjusting, and that's what HHDW uses too. So in brief, age adjustment controls for differences in age distribution across populations. You should use it when you're comparing rates across populations with different age structures. You should not use it when you are comparing groups in a limited age range, say 45 and over. And it's also not necessary when you're looking at groups with similar age distributions. A good example of this is if you're comparing the same population over time. There's no need to age adjust because we can assume the age distribution remains roughly the same. So let's look at an example of why age adjustment is important. We'll examine a very basic measure, mortality rate, for two populations, Florida and Alaska. So we look up the crude mortality rate for these two states, and we see there's quite a difference. Florida's rate is over 1,000 deaths per 100,000, while Alaska doesn't even hit 800. This may make you think we should all move to Alaska. However, when we look at the median age of the residents of these two states, we see that the population in Florida is older than the population in Alaska by almost 7 years. And now if we look at the age-adjusted mortality rates, we see the two rates are more similar. In fact, the rate is actually lower in Florida than in Alaska. This is an example of why it's important to use age adjustment when comparing populations with different age structures. So where does age adjusting become a factor in HHDW? Well, most of the data from the Behavioral Risk Factor Surveillance System, or BRFIS, is provided as both a crude and age-adjusted rate. In general, if you're interested in data for Hawaii, you can use the crude rate. It's the true rate that we see in our population, and that's valuable information. However, if you're planning to compare Hawaii to other geographies, it's better to use the age-adjusted rate. This will allow you to make a more accurate comparison of the rates across the two populations. Another place where you'll see the option for age-adjusted death rates in HHDW is with the vital statistics, specifically with the death data. On the query page, you'll see the same option for crude or age-adjusted rates, and the same general rule applies here as with BRFIS. In Hawaii Health Matters, you'll run into age-adjusted rates frequently for measures of incidence and mortality. If the rate being displayed is age-adjusted, it will say so in the definition. Now let's move on to confidence intervals. Confidence intervals are a wonderful tool. They are very helpful in understanding and interpreting the data we use. In science, we survey a subset of the population and use their answers to estimate the value for the entire population. For the BRFIS survey, we couldn't possibly talk to all 1.1 million adult residents of Hawaii. No one has the time or money for that. So instead, we use a random sampling to select about 8,000 residents to interview each year. And then some sophisticated weighting procedures are applied so that we're able to calculate the estimate for the total population. The confidence interval shows you the probability that the true rate for the population will fall between the given values. So when you see a 95% confidence interval, that means the likelihood that the true estimate lies between the upper and lower limits is 95%. This is what we use on HHDW and Hawaii Health Matters. One nice feature of confidence intervals is that you can actually do some simple statistics with them, and you don't even need a calculator. When you're comparing groups, be it geography, sex, age, race, or any other categorization of the population, you can compare the respective confidence intervals for each estimate to determine if the values are statistically different or not. When you see overlap in the confidence intervals, that means there's no statistical difference between the estimates. However, if those confidence intervals do not overlap, then the values are statistically different from one another. You might have seen this represented as the p-value being less than 0.05. Let's take a look at some examples. Here we see the prevalence of depressive disorder among adults in Hawaii by sex. There's an obvious difference. Those confidence intervals do not come anywhere near overlapping. So here we can say that the prevalence of depressive disorders is statistically higher among females than males. Here's another example. This is current e-cigarette use among public high school students in Hawaii by county. There's some easily identifiable differences. Hawaii County has a higher rate than Honolulu County, but there's some where it's a little harder to tell, like Honolulu versus Kauai. So in this situation, you just consult the data table. And here we can see that the upper limit of the 95% confidence interval for Honolulu County is 19%. And the lower limit of the confidence interval for Kauai is also 19%. This would be considered an overlap, and we could not say that the rates of e-cigarette use among high schoolers in Kauai is statistically different from Honolulu. So where can you find confidence intervals in hhdw.org? They are part of the standard report and will always be shown in the data table. Additionally, you can see the 95% confidence interval for each estimate in the chart. The lines that come off the bar show you the range of the confidence interval. You can see the values by hovering over the bar in the chart. In Hawaii Health Matters, you can do the same thing with the chart. Hovering over a data point will give you the estimate and its 95% confidence interval. Additionally, you can ask the system to display confidence intervals on the chart. If you click the little hamburger icon, you will see an option to show confidence intervals. By selecting this, the chart will now display the confidence intervals for each data point. Know that there may not always be confidence intervals in the system. Here's an example where the confidence intervals began to be loaded with the data in 2009. And also be aware that some data sources may not have confidence intervals at all. Before we go to the demo, I want to highlight one way you can easily move from Hawaii Health Matters to HHDW. When you're looking at an indicator in Hawaii Health Matters that is from one of the data sources we have in HHDW, the source will be hyperlinked. Clicking on that link will take you to that specific indicator in hhdw.org. You'll see the default report showing the 3 most recent years of data for the state, and from here you can select a modified query to begin exploring the data in more detail. All right, let's go ahead and head to the live site. So here we are on the HHDW homepage. And as usual, you can see that you can go to Hawaii Health Matters very easily. If you're familiar with the site, you can go ahead and build your own report. There's also access to some tutorials and our news and announcements. So this is where you can sign up for the coffee break and keep track of our latest data releases. Okay, but we're interested in age adjusting. And one of the data sources that I said provides age adjusted data is the BRFS. So let's go ahead and take a look. Let's look at high blood pressure prevalence. So you'll see here, we have both the crude rate and the age adjusted rate, and these little question marks will remind you of the difference. Let's just look at the crude rate for now. Okay, so here we have the default query report for prevalence of high blood pressure. We're looking at the 3 most recent years of data for the state. We have the estimate, the lower and upper confidence intervals, the count, the average annual estimated population, and a measure of statistical stability. So if you think about high blood pressure, it probably is, like other chronic diseases, affected by age. I'm going to make this just 2023. And I'm going to ask the system to show it to me by age group. So we can see here, yes, there's definitely a difference by age. Let's take a look and see if there's a difference by sex. So here we're seeing that there is a difference. It's statistically significant. You can verify that by looking at the numbers in the table. But this is the crude rate. So let's take a look at the age-adjusted rate. But before we do that, let's look and see if there is a difference in age distribution by sex. I'm just going to jump right in and modify the query. And we'll look at it by age group and sex. One of the other options with the modified query is you can change the way the chart is visualized. So for something like this, I tend to do the grouped vertical bars. And what we can see here, so the blue is male, the teal is female, that in Hawaii, our male population skews kind of young, and our female population skews a little older. So let's see what the age-adjusted death rate for high blood pressure prevalence looks like by sex. So here again, we have our default report. We're going to modify the query. I'm going to look at 2023, and we're going to look at the results by sex. So here we can see that compared to the crude rate, which is here, the age-adjusted rate, that difference is actually greater. So even when you're taking age distribution into account, there is a significant difference between high blood pressure prevalence among males and females. So let's take a look at our age distribution by race ethnicity. So I'm going to select just 2023, and I'm going to ask to see the data by race ethnicity. And I am going to make this a grouped vertical bar. And here we can see the results. So this is showing our different race groups and their age breakouts. And this is a lot of information. It might be hard to really take it all in. What I'd like to do is limit this to Japanese and other Pacific Islander. So now let's take a look at the data. And here we can see that there's definitely a difference in the age distribution of our Japanese residents versus our Pacific Islander residents. So we can expect that there'll be changes in the age-adjusted versus the crude death rates. All right, let's take a look at the vitals. So we're going to go to our death data, and we're going to build a custom death report. We're going to look at the rates by race ethnicity. So let's look at the crude rate first. And the default query will show you the results for all causes of death, but I'm going to limit it to diabetes. So I can go here and look and see that diabetes is one of these leading causes of death. And now we can see the leading causes of death due to diabetes by race ethnicity. Again, this is a crude rate. We're going to now take a look at our age-adjusted death rates. And again, I want to modify this query to make the cause of death diabetes mellitus. And now we will take a look at the age-adjusted rates. So here we can see when we compare to the crude rates, for example, the Japanese population, it has a higher rate of death due to diabetes than in the age-adjusted population. And that's because our population skews older. You can see changes in the other race ethnicities as well. And this is an example of why it's good to check out age-adjusted rates. And here you can also see, for example, the confidence interval. So you can compare the rate in Filipinos is going to be significantly higher than the rate in Japanese. Okay, let's take a look at Hawaii Health Matters. So here I mentioned that you would see age adjusting in death rates and incidence rates. So let's just take a look at a death rate. We'll look at drug overdose death rate. And you can see here that in the definition, it says that it's age adjusted. So looking at our data, Hawaii Health Matters, of course, gives you the definition, a little bit of public health importance, and then also the estimate for the most recent year of data. And then they also provide some comparison values to provide you with a little context for what 19.5 per 100,000 means. So you can see here it hasn't changed significantly from the previous value, but it is trending up significantly. And we have met the Healthy People 2030 leading health indicator target. And below those comparison values, you'll see the trend data. And here for the confidence intervals, you can hover over the data points in the chart and it'll give you the confidence intervals, or you can ask it to show you the confidence intervals. So here you can see the change over time. Below here is where our subgroup data is available. So let's, for example, take a look at drug overdose death rate by sex. The system does some statistics for you. So if it's a red bar, it means it's significantly worse than the total overall. And if it's green, it means it's significantly better. But we can also look at the confidence intervals and see that these two don't overlap. So they are statistically different as well. Okay, so let's take a look at one last thing here on Hawaii Health Matters. Let's take a look at teens who use e-cigarettes. So I mentioned before that when there's an indicator on Hawaii Health Matters that gets its data from one of the data sources in HHDW, the data source here will be linked directly to HHDW and will take you to this specific indicator. So if you've got this information on teens who use e-cigarettes, you can see it by some breakout groups. But say you want to explore it a little further, you can click here and this will take you automatically to this indicator in HHDW. So you can go ahead and modify your query and explore your data more in depth. Now let's give you some time for some hands-on work. Take a few minutes to explore hhdw.org and hawaiihealthmatters.org and answer these questions. Okay, let's run through these activities real quickly. The first one is asking about the highest percentage of 18 to 24-year-olds by county. So we know we're going to want to look at the BRFIS data. We're going to build a custom BRFIS report. And it's asking about age breakdown. And it wants to know for 2023, which county had the highest rate of 18 to 24-year-olds. So here too, we're going to tell it that we want to see the data by county. And this is another situation where I would do a grouped vertical bar. So here we can see all of the different age groups, but one nice thing about the system is that you can click on these and they will toggle on or off. So if we were interested in only 18 to 24-year-olds, here is a more clear visual picture. We also, of course, have the data table. So the answer to that is Honolulu County with 11.8%. Okay, the next question asks, what is the crude rate for Alzheimer's disease for the state in 2023? So we're going to go to our death data. We're going to build a custom death report. And this is asking about the crude death rate for Alzheimer's disease. So let's check our cause of death. Let's see if it's one of our leading causes of death, and it is. And it's asking just for 2023. Okay. So here we can see our crude rate for Alzheimer's disease is 37.6 deaths per 100,000. But the question asks also to compare this to the age-adjusted rate. So let's quickly run that query. So this time we're going to choose our age-adjusted death rates. We're going to modify the query in the same way. Cause of death will be Alzheimer's disease. And we're only going to look at 2023. So here we can see our age-adjusted rate is actually lower than our crude rate. And this makes sense because our population does skew a little older. So the last question is on Hawaii Health Matters, is there a significant difference for adults who drink non-diet soda or pop at least once per day in 2022? So here we are in Hawaii Health Matters. I'm going to just search soda because I feel like that's probably going to pull it. And here we go, adults who drink non-diet soda or pop at least once per day. And we're going to look at the state. And the question is asking if there's a significant difference by sex. And you can see here that there definitely is. We can also put the confidence intervals on to verify that, yes, there is a significant difference. So thank you again for your time today and have a wonderful day.